What is vector embedding? So today, hello world, we are going to understand what is vector embedding and what is the use with some practical examples, and so that we will understand the basic concept that is used in NLP. Welcome to my channel Gen AI LLM at Surf. Let's start happy learning. What are vector embeddings? So based on the definition, this is a way to represent a data. The data can be in the form of words, images or items as numerical vectors in a continuous space that can be 2D, 3D, 5D, etc. The main purpose is to capture syntactic and semantic relationships among the data for the easier processing for the machine learning tools. So the models that we are using to train to train the data with data, those data relationships, how they will help. It helps in forming that particular relationships. What are embedding? Why are embedding important? It basically simplifies the complex data for the machine learning models. It helps in finding the patterns and relationships. It is essential for tasks like NLP, recommendation system and computer vision. How do vector embedding works? Vector embedding works basically into three formats. From data to vector. The process is, first of all, we get the raw data that can be in the form of text, images or audio. Then the transformation happens, that is from data to number format by different algorithms or models, what to vectors, BERT and CNN. And third is the vector representation in the n-dimensional numerical form. The most popular embedding techniques are word to vec, globe or FastTech. Word to vec further used skipgram and the continuous bag of kind of algorithms. In this continuous bag of algorithm, the target is not focus. It's mostly focus on the context or the nearby data sets. Whereas in skipgram they focus on the target. The target how much similar, and based on that they create the relationships. The sentence and document embedding help users BERT, that is bi-directional encoder representation transformer and sentence transformers. Image embedding, they use CNN. I will show you here two examples. One is simple for word embedding and other one is for the real problems like in finding uh, the recommendation systems. So here suppose there are three words, king, queen and man, and this is a very common example, but I am taking this because it you might have gone through this many times, and this will again a revision and help you to understand again. Representing words as vector, step 1. Suppose we are taking here as a three-dimensional, so we are defining king as 0.9.7.3, queen as 0.9.8.4 and man as 0.8.6.2. To understand the relationship, the numbers in the vectors might seem random, but they capture certain relationships. You can see the king and queen are more closer with respect to queen and man. Okay, because king and queen are uh, they are both showing that characteristics of royalty, whereas man is not showing the royalty feature. Example C. If we subtract man from king and add women, we get a vector that is very much close to queen. The king value minus man plus women, it will give us a value of queen. You can see here the girl queen. Queen is much more nearer to women and man is nearer to king. Thanks for this image, CMS Edu. And this is possible because embedding understand the context and relationships like gender and royalty. Now, king and queen are close together because are they are both royalty. Man is near to king but not as close to queen because of gender differences. Why this matters? Search engines. It helps search engines. If you see for royalty, embedding helps the system to understand that king and queen are related. So it's in recommendation system. If you like a movie about king, you might get recommendation about queens or royal families. This simple example shows you how embedding turns complex concepts, a relationship between words into numbers that machine can easily understand. Now I will take you through one more example for the customer behavior in recommendation system. Embedding vector in recommendation system. Imagine you are building a recommendation system for an e-commerce platform. You have thousands of products and millions of users. So each product have and user needs to be represented in a way that captures their characteristics and preferences. Problem with the traditional representation, if you will go for one hot encoding, suppose there are 10,000 products, then you have to if each product is a vector of 10,000 dimension with a single one and zeros, that is, and you for the same users, it's a huge high dimensional data that is inefficient, and complexity in the computational is also very expensive, and no similarity information. One hot encoder don't tell you how similar the products are. So introducing embedding vectors in this problem, instead of one hot encoding, you can use embedding vectors to represent products and user in a dense, lower dimensional space. So it will consume less space also, and computationally also it will be not so expensive. For example, there are four things: running shoes, sport t-shirts, laptop, and wireless headphone. So you can see the vectors for the running shoes and the sports t-shirt, they are much more closer to each other: zero point 0.8, zero point 0.7, 0.2, 0.3, 0.9, 0.85, 0.1, 0.15, 0.3, 0.25. Whereas the vectors for laptop and wireless are very much closer. Understanding the embedding space here. Similarity. The vectors for the running shoes and the sport t-shirts are closer in the embedding space, indicating that they are similar products, while laptop and wireless, they are closer for each other. So they are closer to each other but far from the sports item, reflecting that they are a different category. The operations on embedding, you can use different operations like cosine, similarity, Euclidean distances to find the products or recommendation based on the user behavior. User also represent a vector based on their browsing and the purchasing history. A user who buys running shoes or sports t-shirts, they might have an embedding vector close to sports product. So to recommend a new product, to find a closer vector, we can use Euclidean distance or cosine similarity to the user's embedding vector. And why this matters for the data scientist? Because its efficient representation captures semantic relationships, scalable, so reduce the dimensionality and computational expenses. Similar products and user clustered together, they work well for the large data, making it perfect for recommendation systems, NLP, and more. Thank you, friends, for listening to this subject, and please like and subscribe.